Okay, do you even know who invented the periodic table? So I'm here to share this history of periodic table. So in 1819, in 1869, uh, Dmitry Mendeleev, the Russian chemistry, has created the framework that became the modern periodic table. So he arranged the element according to the atomic weight, to their atomic weight. So if the atomic weight is different and they did not fit into group, he would rearrange them. So Dmitry Mendeleev has made the periodic table. So the next slide is introduction. Introduction of a periodic table. So the elements are arranged in a periodic table, which is probably the single most important learning aid in chemistry. So this is important for chemistry. It summarizes a huge amount of information the element in a way that permits you to predict many of their properties and chemical reaction. The elements are arranged in several horizontal rows in order increasing atomic number from the left to the right on the row. So the rows are called period. They doesn't call a horizontal row. So they call it as period, and they are numbered from 1 to 7. The elements are stacked in such a way that elements with similar chemical properties from vertical columns called group. So group this group like this. So number from 1 to 18. In periodic table has 18 group and 7 period. Okay, we move to the next slide. As you can see the picture, the periodic table, the example of periodic table. As I say in introduction, the rows we call as period in periodic table. So period is arranged from left to the right. So do you ever think what do elements in a row have in common? So the same number, they have the same number of electron shell. For example, period one, first row has a 1 shell for its electron, hydrogen and helium. So all the elements in period 2 have 2 shell of their electron. So the shell according to their period. So if the element had in third row, so they have 3 shell. Okay, we move to the next slide. Column are called as group. What do elements in a group in common? Is same number of valence electrons. So who has element that stay in one same group have a same number of valence electrons. So for example, group 1 has have 1 valence electron, group 2 2 valence electron, group 13 3 valence electron, group 14 4 valence electron, group 15 5 valence electron, group 16 6 valence electron, group 17 have 7 valence electron, group 18 have 8 valence electron, 8 valence electron, except helium who has only 2.
This is an example of periodic table that I found on Google. So, did you know what is matter? where metal is an element that can form positive ion. Apart from that, metal is losing electron during chemical reaction and has metallic bond. Most elements on periodic table are metal. For example, iron, copper, silver, mercury, lead, aluminium, gold, platinum, zinc, nickel, and tin. Next, nonmetal. Nonmetals is a chemical element that mostly lack metallic properties and has low density and high electronegativity. 14 elements are effectively always recognized as nonmetal. For example, hydrogen, nitrogen, oxygen, chlorine, bromine, iodine, helium, neon, argon, krypton, xenon, and radon.
Moving on to difference between metal and non-metal. Metal is solid at room temperature, except for mercury, at its circumstantial state, meanwhile non-metal is gas at room temperature. Metal is a good conductor of heat, and non-metal is poor conductors of heat. For melting point and boiling point, metal has high melting and boiling point, and non-metal has low melting and boiling point. The shape for metal and non-metal is different, as metal is shiny and lustrous, while non-metal is not shiny or lustrous.
We move to the next slide. Transition metal located between group 2 to 13. Transition metal also less reactive than alkaline metal, which is group 1, and also called the D block of the periodic table. Most transition metals are attached to magnet and can form compounds with different colors.
Atomic mass. Atomic mass is the mass of an atom of an element compared with one atom of 12 carbon. It is usually calculated by adding up the total number of protons with neutrons in the atom. For example, carbon here has an atomic mass of 12.01. Next, we have atomic number. Atomic number represents number of protons in the nucleus of an atom in any element. For example, here we have carbon with the atomic number of 6.
Elements in group 18 are known as noble gases or inert gases. Group 18 consists elements of helium, neon, argon, krypton, xenon, and radon. Noble gases are chemically unreactive due to valence shell that are fully filled with electrons. Noble gases also have achieved stable duplet or octet electron arrangements, which causing the atoms of noble gases to not donate, accept, nor share electrons with the atoms of other elements. The atoms of noble gases exist as monoatoms. Did you know that group 18 elements have many uses in our daily life? For example, helium, we use it in the oxygen tanks of divers, neon in advertising board light, argon to fill in electric bulbs, krypton usually we use in flashlight of camera, xenon for anesthesia, and radon to treat cancer. There are two factors that may change in physical properties of elements, which is size of atoms, also melting and boiling point. When going down the group 18, the size of atomic radius increase due to the increase in the number of electrons and electron filled shells. Other than that, the melting point and boiling points of the elements also increases. Increase in the atomic size of elements will increase the attraction force between the atoms. Therefore, the attraction force becomes stronger and more heat energy is required to overcome this force. Next, we move on to the period 3. Period 3 consists of elements sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. The elements of period 3 also uses in our daily life. For example, magnesium as a substance in a lighter, aluminium in cans, phosphorus as a substance in a fireworks, and lastly sulfur as fungicides. Two factors that may change in physical properties of elements across period 3 are size of atoms and number of protons. Going across period 3 from left to right, the atomic size will decrease because the atomic radius decreases. Next, the number of protons across period 3 will increase the charge in the atom's nucleus. The electronegativity of elements will increase because the nuclear attraction force towards the electrons increases. The physical state of period 3 elements will change from solid to gas from left to right across the period. The same goes to metal elements, semi-metal elements and non-metal elements. Sodium, magnesium and aluminium are metal elements, meanwhile silicon is a semi-metal element or metalloid, while phosphorus, sulfur, chlorine and argon are non-metal elements.